Hi everyone, welcome to my channel. Today I am going to discuss about Kirchhoff's laws. Before going to the class, if you like my classes, please like, share and subscribe my channel. There are two laws, that is Kirchhoff's current law and Kirchhoff's voltage law. Let us go through Kirchhoff's current law. It states that the algebraic sum of currents meeting at a junction in a network is 0. In other words, the sum of the currents flowing away from a junction is equal to the sum of currents flowing towards the junction. Consider 5 currents I1, I2, I3, I4 and I5 meeting at a junction. Assuming the currents entering into the junction as positive and currents leaving the junction as negative, we can take the algebraic sum of all of these 5 currents and equate it to 0. We get here I1, I3, I4 are entering into the junction. So take it as positive. And I2 and I5 are leaving the junction. So take I2 and I5 as negative. So taking the algebraic sum I1 minus I2 plus I3 plus I4 minus I5 equal to 0. Or in other words, we can write I1 plus I3 plus I4 equal to I2 plus I5. That is, the sum of the incoming current is equal to the sum of the outgoing currents. Consider a problem. Determine the current in all resistors in the circuit shown. Here R1, R2 and R3 are the three resistors, and let I1, I2 and I3 be the current flowing through these resistors. Now consider a voltage V at node A, and in parallel circuit, these resistors are in parallel. So in parallel circuit, the voltage applied across each element will be equal. That is, across these three resistors, the voltage will be V. And according to Ohm's law, the current flowing through these resistors be I1 will be equal to V by R1 and I2 will be equal to V by R2 and I3 will be equal to V by R3. Now applying Kirchhoff's current law or KCL, that is the total current is 50 ampere. It splits into 3 currents. So we can write 50 ampere equal to I1 plus I2 plus I3, and I1, I2, I3 are V by R1 is 2 plus V by 1 plus V by 5 equal to, taking V outside, 1 by 2 plus 1 plus 1 by 5 equal to V into 0.5 plus 1 plus 0.2, that is V into 1.7. From this we get V equal to 50 by 1.7 equal to 29.41 volt. After getting the value of V, substitute in the current values, that is I1 is equal to V by R1, that is 29.41 divided by R1 is 2, and we get 14.71 ampere. Similarly, I2 equal to V by R2, that is 29.41 divided by 1 equal to 29.41 ampere, and I3 equal to 29.41 divided by 5 equal to 5.88 ampere. So these are the values of current. In this problem, we can find the current flowing through these resistors by the current division rule. That is, the current flowing through this resistor will be equal to total current into resistance through the other branch divided by total resistance. By the current divider rule, I1 will be equal to total current into resistance through the other branch. Here there are two resistors in parallel, so the equivalent resistance of these resistors should be taken. That is, the parallel combination of 1 ohm and 5 ohm is 1 into 5 divided by 1 plus 5, that is 5 by 6. So total current into resistance through other branch 5 by 6 divided by total resistance, that is 2 ohm plus parallel combination of these two, 2 plus 5 by 6, and we get 50 into 5 divided by 17 equal to 14.71 ampere. Similarly, I2 equal to total current into resistance through other branch. Here these two resistors in parallel, that is 2 into 5 divided by 2 plus 5, that is 10 by 7 divided by total resistance is 1 plus 10 by 7, and the answer 29.41 ampere. Also I3 is total current 50 into resistance through other branches 2 and 1 are in parallel, that is 2 into 1 2 by 2 plus 1 3 divided by total resistance is 5 plus 2 by 3, and the answer is 5.88 ampere. Next problem, for the circuit shown, find the voltage across the 10 ohm resistor and the current passing through it. So this is the circuit. Let I1, I2, I3 and I4 be the current flowing through the resistors, and let V be the voltage at node A. According to Kirchhoff's current law, the sum of incoming current is equal to sum of outgoing currents, and here this is the main current and it is split into these 5 currents. So we can write I1 plus I2 plus I3 plus I4 plus 5 equal to 10, and by Ohm's law I1 is equal to V by 5, I2 is equal to V by 10, I3 equal to V by 2 and I4 equal to V by 1. Now substituting this in the equation, we get V by 5 plus V by 10 plus V by 2 plus V by 1 plus 5 equal to 10, and taking V outside, 1 by 5 plus 1 by 10 plus 1 by 2 plus 1, and bring this 5 into this side, we get 10 minus 5 equal to 5. That is V into 0.2 plus 0.1 plus 0.5 plus 1 equal to 5. That is V into 1.8 equal to 5. V equal to 5 by 1.8 equal to 2.78 volt. So the voltage drop across the 10 ohm resistor is 2.78 volt. And we can find the current passing through it, that is the current passing through 10 ohm is I2, that is I2 equal to V by 10, that is 2.78 divided by 10 equal to 0.278 ampere. So the voltage drop across the 10 ohm resistor is 2.78 volt and current is 0.278 ampere.